Hello, welcome back my friends. We are going to learn today relative examples of matrices. And the previous lecture we have learned about multiplication in two matrices. So we know that how to multiply two matrix, right? I repeat once again, you have to multiply first matrix with second matrix by taking corresponding row and column. It means first row first matrix multiply with first column of second matrix, that after first row and second column, first row and third column, first row and corresponding all columns. Similarly, now second row, how can we calculate this second row? Then we have to take a second row from the first matrix, again multiply it first column, second column, third column and so on. And this process we have to done when we completing all rows and all columns. So that is the method. And in the previous lecture we solved several kind of examples. Now next examples are very important. My dear friends, as per board exam, one question can be asked in 4 marks, and that question must be related with multiplication of two matrices, is 100% sure. It means from this chapter one questions 100% asked in 4 marks. So this kind of question now we have to solve. So let us start our today's lecture with this question, and which is your question number 16 as per your exercise 3.2. So example number 16, let us start. A matrix A equals to, matrix A is given as 1 0 2, that after 0 2 1 second row, and third row is 2 0 3. This is given matrix. Then prove that what we have to prove? A cube minus 6a square plus 7a and plus 2i is 0. We have to prove this result. Okay, so we have to start with a cube first. A cube means what? A square into a. So it's a very long process to find a cube. Actually a square and a cube both our required result. So we start with a square. A square is what? Then matrix A means 1 0 2 as a first row, 0 2 1 as second row and 2 0 3 as third row. Multiply it with the same matrix 1 0 2 as first row, 0 2 1 as second row and 2 0 3 as third row. Now matrix multiplication is this: first row first column, as we know. Now I write directly 1 1s are 1 plus 0 into 0 0 plus 2 2s are 4. You are comfortable to this or not? See here once again, first in 1 into 1, sorry 1 into 1 is 1. First row first column, corresponding column just to find 1 into 1 1 plus 0 into 0 0 plus 2 into 2 4. Now first row second column, see here, first row second column 1 into 0 0 plus 0 into 2 0 and plus 2 into 0 0. I repeat once again, first row second column 1 0 0 0 2 0 2 0 0. Now first row third column 1 into 2 2 plus 0 into 1 0 and plus 2 3s are 6, right? Now second row first column 0 into 1 is 0, see here, plus 2 into 0 0 and plus 1 into 2 2, 0 0 2. Now here 0 plus 4 plus again 1 into 0 0. Second row third column, now 0 into 2 0, 2 into 1 is 2 and 1 into 3 is 3. Second row third column. Now third row first column. Let us see, 2 into 1 2, 0 and 6. third row, first column, third row, second column, 2 into 0, 0, 0 into 2 is 0 and 3 into 0 again is 0. It's very simple. Third row, third column, 2 2s are 4 plus 0 and plus 3 3s are 9. So this matrix representing a square, and let us count it. What is this? Then we may say that 5, 2, 8, 1 plus 4, 5, 2 and 8, 0, 4, again 0, and 8, 5 and 13. This is a square, say as result number 1. A square is this. Now what is a cube? Let us calculate now a cube. Then I can say that a cube is a square into a, and a square is the same matrix 5 0 8 2 4 5 8 0 13. This is a square into matrix A. So into matrix A means given matrix 1 0 2, 0 2 1 and 2 0 3. This is a cube. And now let us multiply once again. So how can we multiply this matrix? With the same method. First row, first column. Let us count directly. 5 1s are 5 plus 0 and plus 8 2s are 16. See here, 8 2s are 16. Now first row, second column, 5 into 0 0 plus 0 into 2 0 plus 8 into 0 0. First row, second column. Now first row, third column, 5 2s are 10 plus 0 1s are 0 and plus 8 3s are 24. Similarly, now second row, first column, 2 1s are 2 plus 4 0 0 and plus 5 2s are 10. Now second row, second column, 2 0 0 plus 4 2s are 8 plus 5 into 0 0. Now second row, third column, 2 2s are 4 plus 4 1s are 4 and plus 5 3s are 15. Now third row, first column. This is a simple process like sing a song. 8 1s are 8 plus 0 0 0 plus 13 2s are 26. Now here 8 0 0, 0 into 2 is 0 plus 13 into 0 once again is 0. Second row, third row, second column, 8 0 0, 0 2s are 0, 13 0 0. Similarly 8 0 26. Now 8 2s are 16 plus 0 1s are 0 plus 13 3s are 39. So therefore let us see what is a cube finally. I can say that now a cube is, let us count, 16 plus 5 21 is this, that after 12, and that after 26 plus 8 is 34. Now here is 0 8 and 0, that after 34 once again there, 24 plus 10. Here is 15 plus 8 is 23, and here is 39 plus 16, so is 55, right? 9 plus 6 15, 5 1 3 plus 4 plus 1 is 5. So this is a cube. Now what is our LHS? Our left hand side is a cube minus 6 times a square plus 7 times a and plus 2 times I. Now put all the values, actually all the matrices, let us put here. This is 21 0 34, 12 8 23. Second row, third row is 34 0 and 55. Minus 6 times a square. A square is the matrix from result number 1, 508 508 245, and that after 8 0 13, right? Plus 7 times matrix A. Now Now matrix A means given matrix 1 0 2, see here 0 2 1, and third row as 2 0 3, and plus 2 times matrix I means unit matrix 1 0 0, 0 1 0 and 0 0 1 means identity is there. I just write the reason is from 1 and 2. It means I put the value from result 1 and 2. And finally, what we get? Let us see. Final result I write there 21. Okay, I write directly this result. This 6 is multiplied there. So 21 minus 6 into 5, see here, plus 7 into 1. 7 into 1 plus 2 into 1, see here, is very easy thing. All the 4 matrices I calculate simultaneously. Now 12 minus 6 into 2 here, plus 7 into 0 and plus 2 into 0. That after 34 minus 6 into 8, see here, plus 7 into 2 and plus 2 into 0. I just write all the matrices in a single row. Now the second column, now I write 0 minus 6 into 0, see here, 0 minus 6 into 0, plus 7 into 0 and plus 2 into 0. I think all the values are 0 now. That after 8 minus 6 into 4, see here, 8 minus 6 into 4 plus 7 into 2, corresponding elements just write, plus 2 into 1, right? Similarly here is 0 minus 6 into 0 once again, plus 7 into 0, corresponding element just write, plus 2 into 0. Is it clear? Now the last column, let us write 34 minus 6 into 8, see here, plus 7 into 2 and plus 2 into 0. 23 minus 6 into 5 plus 7 into 1 and plus 2 into 0 once again. And at last 55 minus 6 into 13 plus 7 into 3 and plus 2 into 1. Okay. Now again we solved it. Let us solve it. This is 21 minus 30, 6 5s are, plus 7 plus 2. Similarly here is 12 minus 12 plus 0 plus 0. This is 34 minus 8 6 are 48 plus 14 plus 0. See here, it's very simple thing. Here is 0 minus 0 plus 0 and plus 0, all the value is 0. Here is 8 minus 24 plus 14 and plus 2. Here is 0 minus 0 plus 0 and plus 0, right? Now solve here. 34 minus 6 8s are 48 plus 14 and plus 0. Here is 23 minus 30 plus 7 and plus 0. At last here 55 minus 13 6 are 78 plus 7 3s are 21 and plus 2. Now see what happened. This is 21 plus 7, 28, this one, and 28 plus 2, 30. So 7 plus 2, 9 and plus 1 this. So it will give as 0. See here, this is also 0 and this is also 0, my friend. See, 48 minus 48. This is obviously 0 here. And now here is what? 14 plus 2, 16 plus 8, 24 minus 24 is 0. Here is also 0. What about here? 48 minus 48 is 0. This is also 0 obviously. And here also if you count, 78 is 0. It means this is 0 matrix, which is your RHS. So very interesting example is this. It means this is time taken process, nothing else, just a time taken process to calculating it. Actually you solve this question and you will get 4 marks easily, but here is not important how to solve, it is important that what about your speed to solve it. So just take a screenshot related to it. Okay my friend, now next example number 17. As per your textbook, now you just solve yourself this example 17. Is very easy, but I just give you hint relative to it. Example 17 is, if A equals to, a matrix is given, is actually 2 cross 2 matrix. So you easily solved when 2 cross 2 matrix is given. Matrix A is 3 minus 2, 4 and minus 2 again. 3 minus 2, 4 minus 2 is given matrix A, and I is unit matrix, we know very well. It means identity given as 1 0 0 1. Then find K such that, it means K is any constant such that it is given that A square is equals to, it is given that A square is equals to Ka minus 2i. See here, A square is Ka minus 2i. So I think the question is very easy here relative to this question number 16. I think this one is very easy question and you easily solve it. But just I will give you hint, it means I just derive 1 or 2 relevant step, that after the rest of thing in calculation, I think you familiar with this kind of calculation easily. Here what is A square? A square is equals to Ka minus 2i. Now A square means a matrix 3 minus 2, 4 minus 2. Again we have to multiply with 3 minus 2 and 4 minus 2 very well. And that is equals to K into again 3 minus 2, 4 minus 2. And minus 2 times I means 1 0 0 1, right? This is the first step relative to it. Now what the thing is, you know that multiply these two matrix, first row first column. So 3 into 3 minus 2 into 4, actually plus but negative sign is there. First row second column, 3 into minus 2 minus 2 into minus 2, right? Minus 2 into minus 2. First row first column, first row second column. Now second row first column, 4 into 3 minus 2 into 4. Now second row second column, 4 into minus 2 minus 2 into again minus 2, right? And this is equals to, what about that, 3k corresponding elements, minus 2k, 4k minus 2k, minus this is 2 0 0 and 2. Now you know that just you compare the element on both sides. By comparing all elements, you can find k easily. So by comparing all elements, try to find the value of k, and the rest of work you can solve yourself. So I think no need to calculate it. So the question is very easy. Now the next question is most important example actually. Let us see. The question is this, question number 18. As per your textbook, if A equals to, see here trigonometric function is given. A matrix A is, first row is 0 and minus tan theta by 2. Second row is tan theta by 2 and 0. A 2 cross 2 matrix is given. Then prove that. What we have to prove? Let us see. Then prove that I plus A is equals to. Prove that I plus A is equals to I minus A into, it is given as cos alpha minus sin alpha and sin alpha cos alpha. Then prove that this matrix, let us prove. So how can we prove? Let us see. Actually I just prove RHS equals to LHS in this example, not LHS equals to RHS, because RHS is multiplication of two matrices. So let us start with RHS. RHS is actually I minus A into this matrix cos alpha minus sin alpha and cos alpha. See, is given matrix. I just write I minus A now. What is I minus A? So you know that I means 1 0 0 1 minus matrix A is 0 minus tan theta by 2 and 0, and write this subtraction in a bracket into the matrix is cos alpha minus sin alpha and cos alpha. Now see what to do. Now this subtraction is very obvious. You know that this is 1 minus 0 1. I write directly now this subtraction 1. 0 minus tan theta by 2 is minus tan theta by 2, my friend. This is 0 minus plus tan theta by 2, and 1 minus 0 is 1. It means in this matrix all the terms are trigonometric expression tan theta by 2. Okay, actually here one mistake is there. Here also I think tan alpha by 2 is given. Because of that, here the function is in terms of alpha and here is terms of theta. Is not possible. So change the question. In place of theta, write alpha actually. So here also in place of theta, I must write alpha now. Alpha by 2. Here also alpha by 2 and alpha by 2. Because then you easily multiply. Otherwise angle will be changed. So this is the mistake in your textbook. Okay, now into what is cos alpha? Convert in tan. I think you know the formula very well from standard 11. Cos alpha can be written as 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. I hope you know the formula. And what is sin alpha? Is 2 tan alpha by 2 upon 1 plus tan square alpha by 2. My dear friend, you are familiar with this formula. Sin alpha, again formula 2 tan alpha by 2 upon 1 plus tan square alpha by 2. It means in this example we have to deal with this trigonometric result of 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. Now see what happened. See this second matrix. This 1 upon 1 plus tan square alpha by 2 is common from this. So let us take common. 1 upon 1 plus tan square alpha by 2 is common. Now into here is 1 and tan alpha by 2. Here is tan alpha by 2 and 1 remains. Into the matrix. Here the remaining matrix is 1 minus tan square alpha by 2. Here is 2 tan alpha by 2. Here is minus 2 tan alpha by 2. And here 1 minus tan square alpha by 2. It means now we have to multiply these two matrices very well, and then we will get this kind of answer. Let us see what happened. 1 upon 1 plus tan square alpha by 2. Again here, first row, first column, start with this, then 1 into 1 minus 10 square alpha by 2. First row, first column. Now this 10 alpha by 2 is multiplied there. So 10 alpha by 2 into 2 10 alpha by 2. I write directly this multiplication. 1 into this plus this term. So that is 2 10 square alpha by 2. I hope you understand it easily. Now first row, second column. See here. Then minus 2 10 alpha by 2 plus 10 alpha by 2 into 1 minus 10 square alpha by 2. Similarly, this 10 alpha by 2 is multiplied here. Now second row, first column. What about it? I can say that 10 alpha by 2 into 1 minus 10 square alpha by 2. Yes, second row, first column plus 2 10 alpha by 2. And here is minus 2 10 square alpha by 2. See here. And plus 1 into 1 minus 10 square alpha by 2. So here we have to play with trigonometric formula. Okay. Now just expanding it and try to find the right answer. Let us solve here now. Now is 1 upon 1 plus 10 square alpha by 2. I write here 1 upon 1 plus 10 square alpha by 2 into the matrix is. What about this? I write directly 1 minus 10 square alpha by 2. See here. So 1 plus 10 square alpha by 2. Yes, 1 plus 10 square alpha by 2 is this. And what about here? You just say that minus 2 10 alpha by 2 plus 10 alpha by 2. So is minus 10 alpha by 2 and plus minus 10 cube alpha by 2. See here. This is minus 2 10 alpha by 2 plus 10 alpha. I just multiply this positive sign. Minus 2 plus 1. So minus 10 alpha by 2 plus minus 10 cube alpha by 2. And here is what? Again see here. 10 alpha by 2 and that after plus 2 10 alpha by 2 is there. It means here you have to solve it. 10 alpha by 2 into 1 is this, minus 10 square alpha by 2. So that is minus 10 cube alpha by 2. My dear friend, so I think you easily solve it. So let us see what happened here. 10 alpha by 2 minus 10 cube alpha by 2, this one, and plus 2 10 alpha by 2 and what the term remains, minus 2 10 square alpha by 2 plus 1 minus 10 square alpha by 2. So this is the another thing, 1 minus 3 10 square alpha by 2 is this. I write it directly, 1 minus 10 square alpha by 2 and minus 2 10 square alpha by 2 is this. Okay, my dear friend, here I think cos alpha, yes, minus 10 alpha by 2. Oh, sorry, here is minus 10 alpha by 2 is the term. I think here we have to change the term. Here is minus 10 alpha by 2. Negative sign. So I think first row, first column, there is no problem. First row and second column also there is no problem. Minus 2 10 alpha by 2 and plus 10 alpha by 2. So yes, there is no problem. In second row, minus 10 alpha by 2 is there, my friend. So here the multiplication is this, minus 10 alpha by 2. Here also minus 10 alpha by 2 into 1 is this. So minus here is plus 2 10 alpha by 2. And now let us solve it. So here I think we have to write once again this row. Solve it, then minus 10 alpha by 2 plus 2 10 alpha. So that is only 10 alpha by 2 here. So that is 10 alpha by 2 and minus 10 cube alpha by 2. Yes, minus 10 cube alpha by 2. What about here? 2 tan square alpha by 2 minus tan square. So 1 plus again tan square alpha by 2. 1 plus tan square alpha by 2. This is 1 upon 1 plus tan square alpha by 2 into 1 plus tan square alpha by 2 is there. Here is 1 plus tan square alpha by 2 is there, and here is what? Actually minus minus, here is plus. So again tan alpha by 2 is common. So 1 plus tan square alpha by 2 remains, right? Here minus tan alpha by 2 is common. So again 1 plus tan square alpha by 2 is the remaining term. Here 1 plus tan square alpha by 2 is already there. Now again in a matrix 1 plus tan square alpha by 2 is common. So 1 plus tan square alpha by 2 is common there. Now see which term remain. The remaining term is 1 from here, tan alpha by 2 from here, minus tan alpha by 2 from here, and 1 from here. Now this term is cancelled. So this is our right hand side. Now see how I write this right hand side. Okay. Now observe this matrix. I can write it as 1 0 0 1 plus 0 minus tan alpha by 2, tan alpha by 2 and 0 also. See here I can write. Why I write this? Because now this is the LHS. See I plus A. See here add 1 plus 0 1, 0 minus tan alpha by 2, tan alpha by 2 plus 0 is this, and so is I plus A, and this is actually our LHS. So we prove RHS equals to LHS in this example. So my dear friend, here we stop now. This kind of questions just you find from your material, you can easily solve this kind of questions, and here this kind of expressions with equations is completely over now. In the next lecture we have to deal with another questions related to JEE now from your material. So stay with us. Goodbye.